When you think of a psychedelic experience, the natural assumption is that the brain is going into overdrive. A flood of sensory data and visual geometry implies a state of intense, hyperactive stimulation. But when neuroscientists first put subjects on psilocybin into fMRI machines, they found the exact opposite. Instead of lighting up, a specific, highly connected network of brain regions went completely quiet. Scientists call this baseline resting state system the default mode network. By tracking psilocybin's pharmacological path directly into this network, we can see the exact mechanical process the brain uses to dismantle the sense of self, and why that temporary collapse creates a powerful therapeutic window for treating depression. The default mode network is anchored by core hubs: the medial prefrontal cortex, the posterior cingulate cortex, precuneus, and angular gyri. Even at rest, it is the most metabolically expensive system, burning high amounts of energy while the surrounding cortex remains dark. It uses all that energy to run the machinery of your inner life. This network handles self-reflection, stitches together autobiographical memories, and maintains the continuous neural correlate of the ego. It operates as the brain's internal conductor, actively constraining lower-level sensory systems to maintain a stable, predictable, and cohesive sense of I. The molecule in magic mushrooms, psilocybin, is a prodrug. Once ingested, the body strips off a phosphate group, metabolizing it into the active compound, psilocin. Psilocin acts as an agonist. It binds specifically to serotonin 5-HT2A receptors, which are densely packed on the large pyramidal neurons found in the deep cortical layers of the brain. We know this receptor is the trigger thanks to a blocking agent called ketanserin. If you pre-treat a patient, ketanserin structurally occupies those 5-HT2A receptors. When psilocin arrives, it cannot bind. The neural firing cascade never starts, completely abolishing the psychedelic effects. Ego dissolution is a direct downstream mechanical consequence that is triggered by flipping the single 5-HT2A receptor switch. Once that switch is flipped, the architecture of the brain changes. In 2012, researchers at Imperial College London administered intravenous psilocybin to subjects inside an fMRI scanner. They observed a sharp drop in blood flow and signaling strictly within the core hubs of the default mode network. Look at this fMRI bold signal graph. Under normal conditions, the medial prefrontal cortex and posterior cingulate cortex are tightly coupled. But under psilocin, those waveforms flatten out and break their synchronized rhythm. The network physically decouples. When these core hubs stop communicating, patients report the rigid boundary between their internal self and the outside world softens or vanishes. This scatter plot shows a direct negative correlation. The steeper the drop in coupling, the higher the patient scores on the ego dissolution inventory. When the network that maintains the self loses its structural integrity under psilocybin, the psychological construct of the self dissolves along with it. Neuroscientists categorize this phenomenon under a framework known as rebus, relaxed beliefs under psychedelics. The brain operates as a prediction machine. The high-level nodes of the default mode network continuously push thick downward arrows of expectation, or priors, forcing lower-level sensory data and emotions to conform to a rigid, orderly model of reality. By quieting those high-level hubs, psilocybin removes those top-down constraints. Sensory nodes begin firing without restriction, pushing the brain into a higher entropy, flexible, and mathematically chaotic state. As the default mode network disintegrates, the brain undergoes global integration. Regions that usually remain strictly compartmentalized start communicating freely across their normal boundaries, forming a highly interconnected web of neural activity. Data from clinical trials shows that the magnitude of this specific increase in global integration directly predicts how much a patient's depression will improve. Standard daily SSRI antidepressants, when mapped under the same imaging conditions, do not produce this network-level reintegration signature. The therapeutic value of psilocybin relies entirely on its ability to physically dismantle rigid, punishing neural pathways, making the entire system temporarily revisable. This deeply integrated state is strictly temporary. As the drug is metabolized, the default mode network rebuilds its connections and fully reintegrates within 24 hours, but the downstream effects continue. Activating that 5-HT2A cascade triggers an increase in brain-derived neurotrophic factor. At the cellular level, this drives the rapid sprouting of tiny new dendritic spines along neurons in the frontal cortex. These newly formed physical connection points persist for weeks after a single dose. Researchers liken this to shaking a snow globe. The acute trip briefly melts a brain that has been frozen into a narrow, repetitive groove of depression, and the ensuing plasticity allows the neural pathways to resettle into a healthier configuration. The molecule initiates the shakeup, but the actual biological healing is achieved by utilizing this extended window of structural malleability in the weeks that follow. We can see the clinical result of this plasticity in this Phase 3 data chart from Compass Pathways. It compares a single 25 milligram dose of synthetic psilocybin against a 1 milligram control over a multi-week timeline. That single full dose achieved statistically significant and durable reductions in patients suffering from treatment-resistant depression. While the data is robust, neuroscientists apply strict caveats. Structural correlation across the cortex does not equate to pure causation, and while the default mode network is central to the process, it is only one component of a wider systemic shift. Furthermore, unsupervised use carries severe psychiatric risks. The drug raises blood pressure and can trigger overwhelming fear, lasting distress, and psychosis in vulnerable individuals. A single molecule possesses the mechanical ability to chemically pry open a window of neuroplasticity, but it is the strictly controlled clinical context, the safety protocols, and the psychological support that ultimately structure the healing process.